myself Dr. Preeti Jagmani from Department of Computer Science, Aryabat College, University of Delhi. So in our previous lecture we have begun with a new series which is about computer networks, and in our first lecture, in our introductory lecture, we looked into what actually a network is, what is the basic agenda behind establishing any kind of network, which is kind of sharing the information, sharing the resources. Then we looked into what is computer networks, and we talked about a data communication system and the characteristics on which the effectiveness of data communication system depends. Now moving further in this area, now this data communication system, if we talk about, in the previous lecture we have looked into the important characteristics of that. Now we are going forward with its components. Now a data communication system has 5 major components. First is the message. The message is the information or whatever data you want to communicate from one end to another end. Now what all this information, what all this data could have? This information can include, or any type of information can include text, it can have numbers, it can have pictures, audios, and kind of videos. So any form of media which you can imagine can be included in this information, or this information which is going to be communicated from one end to another end, that is what we call is a message. Second component of a communication system is a sender. So sender, it is very simple. Sender, it's a device that is going to send the message, or that is going to send the data message. Now this sender can be a computer, can be a workstation, it could be a telephone handset, it could be a video camera, and so on and so forth. So it's not like that if we are talking about a communication system, then only a computer can be a sender. No, a computer, workstation, telephone handset, video camera, anything can be a sender. So sender is something or a device which is sending the data, sending the message. After message and sender, we have the third component, which is receiver. Basically a device that receives the message. Again, as the sender can be a computer, workstation, telephone handset, television, anything it could be. Similarly, on the receiver end, the devices could be computer, workstation, television, telephone handset, and so on and so forth. So message, sender, and receiver. After that, the important component is the transmission medium. So transmission medium is, we can say, is the path by which a message travels from sender to receivers. Now this transmission medium or this transmission media could be guided, could be unguided. We will talk about these two in our upcoming lectures. So some examples of these transmission media could be twisted pair wire, or it could be a coaxial cable, or it could be a fiber optic cable, or there is a communication with the help of kind of radio waves. So basically a path, or we can say a media through which the transmission is happening between sender and receiver, or sender is sending a message, that message is being sent to the receiver using a media. It could be a guided or unguided media. That media is known as kind of transmission medium. Now apart from this sender, receiver, message and transmission medium, we have one very important component which is kind of, we can say, is very relevant to a communication system, is protocol. And during this course of this particular computer networks paper, we are going to extensively read about various kinds of protocols. So protocol, if we talk about, basically technically speaking, it is a set of rules that govern a system. So here if we are talking about data communications, so we can say protocol is a set of rules that govern data communication, It is kind of an agreement between the communicating devices. Now, who are the communicating devices? I am just taking a simple scenario, that means communicating devices here are the sender and the receiver. So, some kind of an agreement should be there, maybe about the language, about the speed, or about the way in which the data is being sent. That kind of rules, we can say, which are going to govern the data communication, is known as protocol. And without a protocol, we will be able to connect the two devices, maybe using a wire, but these two devices, unless establish a protocol or unless agree for a particular protocol, they will not be communicating. These will be just two connected device. So, for example, we have two different individuals, one is speaking French and another one speaks and understand Japanese. So, they will not be able to kind of communicate, because there is no agreement, no protocol between these two. So, just as the person speaking French cannot be understood by a person who speaks only Japanese, so a common consensus kind of bridge or agreement, or of a common consensus rules should be there. Now, if we want to look all these 5 components in a single figure, so here we can have, so you can see on the left side there is a sender, then on the right side is the receiver, then between sender and receiver there is a medium, and there is a message which is kind of an information which is to be exchanged or which is to be sent from sender to receiver. That message is actually traveling on that particular medium. So, we have sender, receiver, message and medium, the 4 components. Fifth is protocol. Now, on the sender side and also on the receiver side, you can see a set of protocols. So, set of protocols here is being shown kind of we can say just a block structure with a very elementary idea, which says there are certain rules, rule 1, rule 2, rule 3 till rule n, and which are being followed by sender, and they are also being followed by the receiver, and this whole communication is being governed by these rules, this set of rules, and this set of rules is what we call is protocol. So, in this figure we have witnessed all the 5 we can say components of the communication system: sender, receiver, medium, message and the protocol. Now, if we talk about the kind of types of communication between two devices, so we generally call this as the data flow. So, data flow is the communication between two devices. Now, this can be of 3 types. One is a simplex, another one is half duplex, and third one is full duplex. Now, let us try to see all these 3 categories. So, simplex communication, if we talk about, now here is a kind of figure which is giving you an idea about the simplex communication. So, on one sender end we have a mainframe which is sending some information to the monitor. What is the monitor which is available at the receiving end? What is the direction of data? The data is always being passed from mainframe to monitor, or it will travel from mainframe to monitor. Mainframe is in the sender position, monitor is in the receiver position. So, this is actually a simplex kind of communication in which in the simplex mode the communication is unidirectional. We can say it is just a one-way street. Either one of the 2 devices in the link can transmit, the other one can only receive. Here that is why I have named the sender as the mainframe, while the receiver is being named as a monitor. So, monitor is not going to generate any data, so it is not going to send any data. As far as mainframe is concerned, yes, it is generating a lot of data and it is sending to monitor. So, one particular one-way street, we can say, only one of the 2 devices on that transmission media or on that link can transmit, other the device can only we can say receive it. Now, if we talk about other examples, as I have told you, the monitor is the monitor and the mainframe system. Keyboards and traditional monitors we can say are the examples of simplex devices. So, a unidirectional communication mode. Moving further, after simplex we have next mode as half duplex mode. So, half duplex, if we see, each station is a sender and receiver. So, each station can both transmit and receive, but not at the same time. When one device is sending, the other can only receive, and vice versa. So, now we cannot say sender and receiver. For a moment they can be sender and receiver, but there can be role reversal also. But in simplex there is no role reversal, in the sense mainframe is always in the position of sending, while monitor is never in the position of sending. So, it will not send. As it will not send, mainframe will not receive. So, mainframe is always sender, monitor is always a kind of receiver. But here if we talk about, only one device at a time can send, other can only receive, but this will happen vice versa. This can happen vice versa also. So, for example, we have citizen band radios, or maybe even the most common example of the half duplex communication mode is walkie talkie. Both the sides can communicate, but one at a time. So, if we want to have a look of this half duplex, so here you can see there are two stations, that is why I have not named them as sender and receiver, or maybe. So, there are two stations, let us say station 1 is station 2, and at a particular time, let us say T1, the data is being sent from station 1 to station 2. So, station 1 is sending, station 2 is receiving. Maybe on the very next point, direction of the data, if you can see in the figure, is being now reversed. That means at a particular, or after time T1, at time T2, this station 2 can send the data to station 1. So, these are the kind of we can say this is the half duplex system, in which both can send, both can receive, but not simultaneously, but one at a time. So, simplex, then we have seen half duplex, and now coming to full duplex. Full duplex says both the stations can transmit and receive simultaneously. And one common example of full duplex communication is telephone network, where two people are communicating using that line, can both talk and listen at the same time, and this full duplex mode is used when communication in both the directions is required all the time. So, three modes kind of we have seen, and this is the kind of we can say a very simple block diagram of a full duplex communication, in which you can see direction of data all the time can be from station 1 to station 2, or vice versa, which is from station 2 to station 1, and this can happen simultaneously also. So, simplex communication mode says the data will travel as if it is in the kind of one way street. Then if we talk about half duplex says the data will travel in both the direction, but not at the same time, and the full duplex communication says the data will travel in both directions, and there can be a simultaneous communication also. So, these are the three modes of data communication: simplex, half duplex, and full duplex. Now, if we look about we have looked into what actually computer network is, why do we need a computer network, or what is the basic agenda behind establishing the networks. Now, let us also try to see that how does this computer network, or how does a computer network work. Now, as a communication system, we understood the terminology, in the sense sender, receiver, message, transmission, media, protocols. Now if we talk about what mechanism, how does a computer network work? So here I am going to give you a very macro level idea, brief idea about it. The details of this, how does a computer network work, is going to follow in the upcoming lectures. So basic building blocks of computer networks, if we talk about, is nodes and links. There can be kind of nodes. Now nodes, again here is a new term. Any devices those are connected to the network are known as nodes. These nodes could be computers, servers, printers, or any other type of internetworking devices called routers, switches, which are required for data traveling from one particular network to maybe to some different machines. So nodes are the devices that are connected to a network, and there can be many examples of these nodes, and these nodes along with the links are basic building blocks of computer network. And a network node can be illustrated or can be explained as an equipment for data communication. Now not necessarily being the sender and receiver, any other kind of equipment which is related, which is required for data communication, could be a modem. So for example, what does this modem do? Conversion of analog to digital and then digital to analog. So that is also kind of a node. Then we have routers in required for routing the messages, the packets from one particular place to another, or it could be an a full-fledged computer, it could be a simple data terminal. So any entity here can be a node. Now if we talk about the next term within the building blocks of the networks is the link. So link can be link is actually we can say transmission media, wires or cables, or kind of a free space of for wireless networks. Protocols we have kind of understood, because this working of computer networks can be governed with the help of protocols, and these protocols are going to help us in sending and receiving the data from these nodes via the links which allow computer networks to communicate. So protocol is also very important. Here one important thing is each device here has an IP address, and that address will help in identification of a device. So IP address is kind of we can say different for different devices. So we connect the computers, then we establish a protocol set, and then we can kind of we can say start the communication. If we talk about what do these computer networks do, looking into the history or looking into the evolution of these computer networks, these are first developed in kind of around 1950s. These were for military and defense purposes, and at that point of time the main usage or main purpose of these networks which were established, and those were in kind of we can say very primary stages. At that time they are mainly used to send data through telephone lines and had a very limited use in business or science. But nowadays it is not the kind of systems. Nowadays it is not the scenario. So today's computer networks are essential for businesses also. For example, we can see network of banks, that is important for businesses. And modern networks, if we talk about, they are not just connecting the devices, they offer much more than just the few devices or kind of various devices connecting. And these modern networks actually play a key role in helping businesses adopt to the digital world and then succeed further. So if we talk about what apart from this exchange kind of or the basic agenda, what these computer networks can do. So the modern computer networks, if we talk about, can work virtually, by different medias, we can say. They also can connect on a very very large scale. The earlier systems were, it is just having kind of few machines or few nodes connected to each other, but nowadays these networks have become so sophisticated that they can connect on a large scale. They also kind of adopt very quickly with the kind of changing systems and settings, and also they help us in keeping data secure. So, for example, there is a network of an organization or within an organization, and if we want the data within the organization to be secured, that cannot be shared outside this network, all those provisions can be done with the help of firewalls. So, that means networks are also equipped, or we can say are also can help you in keeping your data secure. Now, if we talk about communication, as we have seen in our previous lecture, we have seen some important characteristics which are required for we can say measuring the performance of a communication system. If we talk about computer networks, to be very specific, we have different criterias which a network kind of must meet in order to kind of we can say measure the performance. So, most important of these are we have reliability, we have security, we have performance. So, these are the criterias a network must meet. So, we have performance, we have reliability, and we have security also. Let us try to kind of look into all these criteria one by one. And these are actually very important criteria for a computer network. Now, performance, if we talk about, you understand the meaning of the performance, but as far as computer networks is concerned, this performance can be measured in many ways. Two of the criteria could be transit time and the response time. So, transit time, if we talk about, is the time required for a message to travel from one device to another. So, that is the transmission time, we can say, or transit time, time required for a message to travel from one device to another. If we talk about the term response time, it is the elapsed time between an inquiry and a response. So, for example, I have written let us say google.co.in or google.com. The moment it is going to be kind of displayed on my screen, the difference between the moment I have kind of I have showed the request and I have got the response. So, the response time is the elapsed time between an inquiry and a response. So, obviously performance of a network, if we talk about, would like to have kind of very very small response times and fast transmission time. So, that means transmission time should be fast, the data or the message should travel from one particular device to another swiftly, or we can say in a fast manner, and response time is the time elapsed between an inquiry and a response. So, shorter response times are always required and efficient transmit time is also the key thing. Performance of a network, now these transit time and response times are basically dependent on various factors. So, for example, we have so many number of users, or we are having less number of users, is going to impact the performance of the network. Type of transmission medium, if we are using a fiber optics, that is faster as compared to twisted pair cable. So, type of transmission medium, obviously that is important, and what kind of hardware is being connected to those within that network, what are the capabilities of that connected hardware. And it is not only the hardware which runs the show, it is also the efficiency of the software which is being kind of working behind the scenes. So, a performance of a network depends on number of users, high or low. then types of transmission medium, guided, unguided, then slow transmission medium, high, kind of fast transmission medium, what are the capabilities of the hardware connected, how many lines at a time or how many users at a time it can support. Then we have efficiency of the software as also one of the kind of very important parameter. Then if we talk about performance, we have seen two terms within that. One is the transit time and another one is the response time. And if we want to actually evaluate the term or evaluate the performance of any system, in case of networking or in case of computer networks, this performance can be evaluated by two metrics. One is throughput and another one is delay. So, delay is obviously, we need smaller delays or we need less delays and we need more throughput. So, throughput, if we talk about, is actually measured in BPS, which is bits per second, but it can also be measured in packets per second or other units depending upon the context. So, throughput basically is the rate at which the data is successfully transmitted over a communication channel within a given time period. I repeat, throughput refers to the rate at which data is successfully transmitted over a communication channel with a given time period. It essentially measures the actual amount of data which is being delivered successfully, while if we talk about bandwidth, it represents the maximum capacity. So, throughput is different from bandwidth. Bandwidth represents theoretical maximum capacity, while your throughput measures the actual amount of data successfully delivered. So, performance, if we talk about, we need more throughputs, we need high throughputs, we need less delays. But if you can see these two criteria, they are often contradictory. If we try to send more data to the network, we may increase throughput, but we increase the delay also because of the traffic congestion in the network. So, all these parameters or all these kind of, we can say, performance metrics does not operate alone. There are so many interconnected kind of technicalities on which all these things depends. Apart from performance, if we talk about, I have also mentioned the two terms which are reliability and security. Now, in addition to accuracy of the delivery, network reliability is also very important, which is measured by the frequency of failures, which is the time a network takes or the time it takes for a link to recover from a failure, and the network's robustness in case of a catastrophe. So, for example, we need high reliability or we need kind of less frequency of failures of computer nodes or computer links, we can say. We need high robustness. So, reliability is also a criteria. Then we have security. So, security nowadays is much of a kind of a common topic which is being talked a lot. So, network security issues include protecting data from unauthorized access, protecting the data from damage and development, and implementing policies and procedures for recovery in case of breaches and data losses. All these things are covered under kind of, we can say, network security, which is altogether a very a separate domain if we talk about it. So, our network should be or must be kind of, we can say, secure, it must be highly reliable, then performance should be good. That means the throughput should be high and the delay, or which we call latency, also must be kind of very less. So, in this lecture we have looked into the components of a communication medium, and after understanding all the components of a communication medium, we have looked into the performance issues of the computer networks. Here is a list of references which is being used for the preparation of lecture. I hope you have enjoyed this one. I will see you in the next. Till then, take care. Goodbye.